This presentation describes the stroboscope model created by the CPM add-on for the probabilistic scheduling of a PERT or CPM precedence network. This figure illustrates a CPM or PERT precedence network with 6 activities, A, B, C, D, E, F, that have probabilistic durations. The CPM add-on provides stroboscope statements that allow modeling this precedence network directly by specifying its activities, their duration distributions, and their precedence relationships at the CPM level. The CPM add-on then creates a hidden equivalent stroboscope model that it sends to Stroboscope to perform multiple replications of the project and collect statistics about the project and its activities. The following sections describe the hidden stroboscope model created by the CPM add-on. Resources. The only resource type in the stroboscope network created internally by the CPM add-on is called time. Time is a generic resource that signals that the previous node has finished. It is defined by the statement genType time. The stroboscope network definition. CPM activity C is represented by 2 nodes, a consolidator named in_C and a normal activity named C. The consolidator and the normal activity are connected by a link named IL_C, which stands for internal link for activity C. The resource that flows through that link is time. The link that connects the predecessor activity A to the successor activity C is named fs_A_C and connects a normal activity A to consolidator in_C. The resource that flows through the link is again time. The CPM start activity is represented by the Q private start Q and the combi private start combi. The Q private start Q is initialized with 1 unit of time to allow the combi private start combi to start during simulation and perform 1 replication. The Q and combi are connected by the link private start link. The CPM end activity is represented by a consolidator named private end. This consolidator finishes when all the CPM activities with no successor have finished. If a CPM activity A has no predecessors, then it is a successor to the starting combi private start combi. The link name is fs0_A and carries resources of type time. If a CPM activity E does not have any successors, then it is a predecessor to the consolidator private end, which represents the end activity. The link name is fs_E_end and carries resources of type time. The CPM forward pass. To start each replication, Q private start Q is initialized with 1 unit of time, which allows Stroboscope to simulate the project once and perform 1 CPM forward pass. In each replication of the project, the duration T of each CPM activity X is represented by the duration of the single instance of the normal activity X. Normal activity X starts when its consolidator in_X ends. The consolidator in_X ends, that is, it consolidates, when it has received 1 unit of time from each of the predecessor normal activities W. During simulation, a normal activity X ends after an interval of time t from its start. When normal activity X starts, it should receive 1 unit of time from its consolidator in underscore X. However, if activity X has multiple predecessors, W, then its consolidator in underscore X may have received more than 1 unit of time. Thus, the release amount for link IL underscore X must be set equal to 1 unit of time to make sure that the normal activity X receives exactly 1 unit of time. This ensures that when each normal activity X ends, it will send 1 unit of time to each one of the consolidators in underscore Y of its successors Y. The project ends when the consolidator private end ends, that is, it consolidates. The consolidator private end ends when all its predecessor normal activities have finished and have sent it 1 unit of time. When the consolidator private end ends, that is, it consolidates, Stroboscope has performed 1 replication of the project and knows the duration, cost, early start date, and early finish date for each activity. The CPM backward pass. The CPM add-on then performs the CPM backward pass for this replication by using the custom private function private back pass. In contrast to the forward pass, which is done by stroboscope elements and makes simulated time go by, the backward pass calculations for each replication are performed instantaneously by the CPM add-on. The backward pass calculations are the first action performed when the consolidator private end finishes, that is, when 1 replication of the project finishes. This is done by assigning the result of the function private back pass to the dummy save value CPM add-on. CPM statistics. As soon as 1 replication of the project is finished and the above on-end action that triggers the backward pass is performed, Stroboscope uses separate persistent collectors to collect 1 sample of each of the following metrics: the duration, cost, early start, early finish, late start, late finish, total float, free float, and whether the activity was critical, which is a 0-1 value for each activity, and the project duration and the project cost. These metrics are collected into separate collectors by separate on-end actions that are performed after the on-end action that performs the backward pass. For example, the persistent collector for the project duration is named project dur, and it samples every time consolidator private end finishes. In addition, Stroboscope collects 1 sample of the following metrics for each CPM activity: its duration, cost, early start date, early finish date, late start date, late finish date, total float, free float, and whether it was critical in this replication. The relevant statements are also on-end, private end collect statements that collect into a private collector the appropriate CPM metric. Multiple replications. The statements inside a while loop initialize the queue private start queue with 1 unit of time and then run 1 simulation of the project using the simulate statement. Thus, each simulation inside the while loop simulates the project once and performs 1 CPM forward pass and the calculations for the corresponding backward pass. The while loop allows Stroboscope to simulate the project multiple times and collect additional samples for the above matrix. The number of replications for the project is specified by the CPM Addon statement CPM replicate, which is followed by an expression that defines the number of replications. This statement performs number of replications of the CPM network, where each replication simulates the CPM network once and produces the report of the CPM report statement. The CPM report statement produces the two tables described earlier. The first table gives statistics about the entire project, and the second table provides statistics about each activity in the project.